All right. Oh, yeah, all right. All right. Okay.
Because why
So
not?
we're headed towards the end of the semester, as you all know. Yay! Anyway, I will be talking about experiment 22. Look at the calendar. That's why I projected the calendar. I just took the section of the calendar out so that you can see this is for the month of November, right? This is in your green sheet. I'm just pulling it out so you all can see where we are, okay? So this is the coming week, right? So mark under red, okay? Only the Thursday class will start with the electrochemistry because
Yeah.
we have Turkey Day on the following Thursday. Therefore, the Thursday group has to do their 22 before everybody else. Are we following this? Okay. So today I will be talking about 22. I will talk about 25 next Friday. Okay. So, but you have 23, 24, 25 are due. Okay. So let me go this. Continue. Experiment 22 quiz will be the take home, as you see here, take home quiz. All right. Possibly on Canvas. That's what Professor St. Master will probably be communicating with you in that regard. Okay. You know, somebody's approached me, and we have 22 before 30 days so we could enjoy. It's not up to me. It's Professor St. Masters who takes control of that. All right. So lab exam 2 will be coming up the week after Thanksgiving. All right. So it'll be on experiment 18, 20, 21, 22. Mostly the equilibrium stuff is what you're doing in this part, right? So when are the due dates? Experiment, you are owing us till 21, which is the KSP experiment, right? Experiment 22 is due at the start of December 1st, okay? December 8th is, that's already the week of the checkout. That Monday is due your 23 to Professor semester. Okay, you have to type it up. You all know the drill. She would accept it earlier if you haven't done it earlier. All right, she does the grading, not the lab PA. That's the only lab that she grades fully and provide you with the grade. So in the end, all the teachers in the lab have to compile all your lab report grades and calculate it, weigh it out, send it to her. All the lab report, your lab exam, and your quiz are all computed in separate columns, and then she adds in your lab 23 and finalizes a grade of some sort that is your lab component, decides who gets to repeat the lab and not, sends it to Professor Delargo. Delargo does the final M1 grade. Are we clear? So when you ask the lab instructor what grade do I have, we don't have your grade. Okay, it's pretty complicated because we have to weigh everything. So in the final thing, what we do, so if you ask us, we can show you what we have recorded so that there is no issue about our misrecording, that's why we post them, but we don't provide you with the grade. Are we clear? Okay? So it's not that we're hedging, okay? So protocol for experiment 24 and 25 have to be typewritten. As you know, 24, which is the absorbance one, 50 points is accrued from your lab work. If you got the absorbance on the first try, it's 50 points, and then continual reduction. Then another 50 point comes from your lab report, right? Your lab, it's not really a full report. You just have to write, just like in the example in your manual, how much of the chemicals you're using, how much of what are the equipment you're using, and then the procedure. Now, please be very clear. If you're using iron chloride hexahydrate, put in the full name. You have to recognize that the name has to be written completely, or else it's like your lab manual, right? We no hydrate if it's not a hydrate. If you're telling people to weigh this substance, it's either hydrate or unhydrate. Be very clear with that, right? Okay, if you say iron 3 chloride, give it the right name if you're gonna spell it out. Are we clear? Because those are misspelling, grammar being incorrect. It's a very simple, it's just one page. Front side is your procedure, back side is your calculation. Show your calculation clearly. If you scribble and dribble and we can't figure it out, those are points deducted. Sig fig, watch your sig fig. Are we clear on that? Okay? All right. So, protocol for 24-25 are due by the last lab meeting to your lab instructor. Are we clear on all this? These are all, I just cut and pasted what are in your green sheet. These are all in your green sheet. Okay, and there's one copy of this, not in this order, posted in your lab as well. All right? So, okay, now I'm going to talk about experiment 22. I know you won't be doing this until the following week. So what are we going to do? You all have had electrochemistry in lecture? Yes, okay. So what are you going to do is you're going to go to the lab because you've seen all this, you're just copying down half cell potential. You're going to actually see in the lab what's going on, right? So the goal is you're going to measure voltage generated by combining different half cells. For the first part will be under standard conditions, which is 1 molar. And the second part that you're going to do measure, you're going to do some dilution and do half cells of diluted sample, right? So you're going to be working in groups of 2 or 3 students. Now, in this lab, all the waste will be collected. Okay, these are heavy metals. We don't pour them down the drain. So there will be jugs in the hood. All the solutions will be in waste jugs. The metals that you're going to be using as part of your electrode, you will just make sure you know the identity so you can return them to the bottle. We can reuse this so we don't save our lab fee. What you're going to do is when you're done with it, rinse it out, pat it dry, and put it back to the proper bottle because they can be reused. Okay? So, part A, let's see, it's going to cover all of it. Okay, everything will fit on one screen. All right. I don't know how to do this. Sorry. My screen gets smaller when I get this on. So we want to, so part A, you're going to do all 1 molar solutions that we prepared for you in the lab, okay? So we want to minimize solution use. So go to the reagent area and bring only 30-50 ml beaker so that you're not over pouring, okay? Because you need very little of the solution. We don't want to waste, and the service center has to prep it again if you went overused, okay? So do not use large beakers because you end up filling away more than you need. So label your beaker so you know what you're putting in, okay? Remember to only place a metal in a solution of its ion. What do you mean? So when we're measuring, you're going to check a copper cell, let's say. If this is the Cu plus 2 solution, and this is your zinc, because the ions have to be Aq, right? When you're going to put the copper strip, it has to be copper in copper and zinc in zinc. You don't swap, okay? Because you'll have electrochemistry then. So mixing metal with a different metal ion can result in a redox reaction that damages the solution and the metal. You start plating on one. So we don't want to do, don't put this, if this is zinc metal, this is copper metal. No, copper metal has no charge. It's elemental, it's 0, right? Solutions are like copper nitrate or zinc nitrate when we say that. I hope you make the distinctions by now. Okay. So, don't forget the salt bridge. There will be a little plasticky thing that is the salt bridge. You'll see that it's a small little plasticky thing that you're going to put between the two. Okay? one is a black one, okay? And there'll be several switches here, AC current or DC current. The voltage clip, okay, you will find the one that has the V over here, that has, I don't know if it's over here or not, I don't remember what voltmeter looks like, but you want to get the knob pointed to the one that is direct current measurement, okay? Because there'll be ones that are, we don't want this one, that's AC, alternating current. Are we clear on this? Yeah, you following me? Okay. Measure the voltage the moment you connect the clip on it and to do the reading. The reading will not stop. It will shift because you'll start having electrochemistry. So just do the first reading because it's not going to stay stable in one reading. You following me? Okay? So when you flip it on, and so waiting will give you full results. So just flip it on to the reading. If the reading is showing negative, okay, you've got it flowing the wrong way, right? So if the potential is negative, switch the clip, not the metal. So if I have red clip on this one and black clip on this one, and you're showing negative, you take the clip off the metal and you flip. Don't put this and put it in different solution. You following me? Okay. You're measuring the potential for 6 cells made from combining 4 different half cells. You will follow the instructions in your manual. I'm not going to go. You need to learn how to read as well. For your worksheet, you have a form like this. And in the past, it says Part A. And it says cell number, according to from your manual. It says 1. She had put in red clip, and in her grading, she's writing it as a cell. So write in what cell it is, so you can just say it's a copper zinc. Okay? Because what she has written is red clip. Okay? What I'm going to do is cross out the red clip or circle the red clip. Okay? So if it's copper zinc, see which one the red clip is on copper or zinc, just write copper zinc and circle the one that is going to be, that you see is red clip. Are you following me? Okay? So change it on your form so you know what you're doing on that. Because if you just write what the red clip is, you don't know what other side it is, right? And aside from that, you're going to be writing the measured voltage, you're going to be putting it in your manual as you work it. On the side here, there's a calculated voltage that you have to show works down here for just the first one. You guys know how to do that reduction potential and all that. There's a table in the back, R13, that has the reduction potential, and you know how to switch, right? Okay, so this R13 calculate the expected potential using the table of potential in the back of the lab manual, R13. If it's not jiving, don't worry about it, okay? Because what we're measuring it may not reflect what reality is. It will be close. Some of them will be off, okay? There's some issues. That's, I'm not going to go into, okay? So don't sweat it. Just do your calculation right. Do the measurements. Are you following? Okay. So, for example, I'm just shooting through this. They're all reduction potential, right? The plastic electrons in the reactant part. And what do? One of these reactions has to be flipped because one of the reactions has to be an oxidation when the two half reactions are combined. Potential, net potential has to be positive, right? You guys know this, right? Yeah? Okay. So if you flip it, you flip the zinc, the one that's more negative is what you flip, right? The one that's more negative wants to be oxidized, right? So what I tend to do, which is not, I don't know how you're shown to do it. Typically, I would rewrite it as cadmium plus 2 electrons goes to cadmium plus 2. Am I going wrong? Plus 2 here. It's not making sense. And then when I flip it, I will say the E of this is whatever value. I will rewrite rewrite the equation and write zinc will be zinc goes to zinc plus 2 electrons. I will write how it's supposed to be and change the sign of that already. I will just put the value in the correct positive and negative. So in the end, you know that it's 2 electrons here, cancel. You have, and all you have to do is add it up. If you don't write it down in that format, your brain keeps having to do flip negative to positive and you can't remember which. You get totally thrown off. Are you following me? Okay. So when you end up with Nernst equation, when the electrons aren't the same, you have to do multiplying so that the electron exchange is equal, right? But when we do that, do we multiply the electron as well, potential, reduction potential? You do not. Are you following me? So you're going to have a question in the back that's Nernst equation. I'll show you an example in a moment. Okay, what I mean. So you know how to do this. This is easy. Part A, correct? Part B, you will prepare 2 dilutions of copper plus 2 solution. Make cells by pairing up 2 different concentrations. Because the 2 Rath reactions are the same, the only effect is due to the concentration difference. The Nernst equation discussed in lecture then simplifies to this, right? I told you this in aside. That is the equation you're going to need for part 2. Following me? Can I read it? Oh my God. Somebody reached out to close it. Maybe write it on the board. Can you move that? Thank you, Carter. All right. So this is the equation. Notice that there is a negative sign in front, right? Don't lose that. Okay? So I'll do an example of copper. It's just dilute over concentrated. Wait, there should be an N. Let me get this straight. There should be an over the number of something is missing. Whoa. There should be an over N. Underline, and there should be an N there. That's the number of electron exchange, right?
It's this.
Right? It's the log of the dilute. You do dilute divided by concentrated, and you take the log of that. Got it? I just didn't do this is not the log of dilute, but the log of dilute over concentrated. You got it?
That number's a constant.
Got it? Got it, right? So
What is
if you're doing what I'm trying to
That's the
tell
number
you
of
is this.
electrons transferred. You know, like when you're doing your redox equation.
Right?
It's like literally the lowest common denominator. Yeah. So,
Okay.
You literally keep those in your pocket.
yeah, I got them for the whole semester. It's been helpful. I feel like you're a nerd.
I don't work well with flashcards.
Really?
Never been able to study. I study by rewriting and repetition. And for me, like flashcards, I zone out and then just memorize it. So.
See, I'm just kind of more like as I'm doing something, like, the fuck is that equation? Oh wait, I got it. Right now, it's just totally like nerded out right now.
Good point.
So, what do I have to do? Which is the one that I need to flip?
I've been trying a bunch of different shit this semester, just trying to see like what works and what
When I'm
doesn't.
working it, I do this. I said, this is going to flip. I will sort this out and I'll flip it. So I'll say copper,
I hated
copper plus 2
the classes like
electrons.
psychology and
And
philosophy.
I
So
would
it
just
seems
say
so
for
different
the
from this.
E
Just
that I need will
totally
be negative
fucking gotta switch gears.
Okay, so far so good, right? Now, I need to balance the number of electrons. When I have 2, I have to multiply this by 2, right? So the number of electrons is the same. I do not multiply the
And she's explaining how
potential.
to get in.
I do not multiply the potential. Are we clear? Okay. So now I will have the ending will be Fe plus 3, right? Plus, okay, and then I'll go on the other side and I'll say I have 2 Fe plus 2. Okay? Then I'll just copy this down, right? And I'll have this. Make sure you're copying. You multiply, I multiply first and I leave space so that you don't forget. Work one at a time so you don't lose stuff. Are you following me? So, my E naught is going to be 0.43 volts. Are we good so far? 46. Where's my range? I'm sorry, this is 0.77. Okay. What does Nernst equation do? Nernst equation takes care of anything else that is going to be it's going to be the Nernst equation corrects for concentration. If there's concentration on this, let's say this is 1 molar or 0.010 molar, there will be concentration on all this term, right? So what you're going to do is the E of the whole cell will be E naught, which is the standard, right? Minus 0.0592 over N. Get 2 electrons for here, this is going to be 2, right? And then you're going to do the log of, just like the KEQ, the product over reactant, raised to its power. You following me so far? It's going to be like that of the KEQ, so it'll be Fe concentration of Fe plus 2 squared times the copper, because that will be AQ, there will be a concentration on those. Because ions are usually made in different concentrations. So it will be the concentration of copper, okay, polarity, over, since this is a solid, it's not going to be in AEQ, right? And it will be Fe plus 3, the concentration of raised to its power, right? Squared. So, you will have one problem in the back that you're going to solve that is the Nernst equation type deal. Okay? And it's pretty elaborate. Okay? So, I'm giving you this so that you know how to do it. Just the changes from the standard. This is the E naught, right? You add that in, and then 40592 divided by the number of electron exchange that you balance out. Okay? And log of just like the KEQ type term. You following me? Are we good? Okay. That's it. That's it.